Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching Zero to Hero. No, this is a hero to superhero series about programming, coding, artificial intelligence, neural network from scratch, right? Anyways, so guys, let's see where how far we have reached. So let me go through my IDE. I am using the Visual Studio IDE. Wow. So we started with initializing the neural network. This is the code which you understand very clearly. Then we moved on to activating the neurons. You understand this pretty good. You guys are expert. And then we did the neuron transfer, which is this code. So you understand this as well. And we tried the forward propagation between the input to a network within the input and output layers. So you understand this very clearly. And then we also tested our entire bunch different pieces of code together. We got a pretty good output. The neural network, the partial weights started working. Now we are going to look at the back propagation error. So what it means. So basically, I'm going to just give you a pretty high level stuff. Though the back propagation algorithm is named for the way in which the weights are basically trained, right? So let me repeat this. It's an algorithm, right? The back propagation is an algorithm which is named for the way in which the weights are trained. Error is calculated between the expected outputs and the outputs forward propagated from the neural network, right? So these errors are then basically propagated backward from the reverse order through the network from the output layer to the hidden layer and assigning a blame for the error and updating weights as they go. Blame in the sense it might say, hey, this is a cat. No, this is a dog. No, this looks like a combination of a cat and a dog, right? So it gets confused. The network gets confused and the weights are not assigned. So from the output layer, it again comes back and says that these are scrappy data. So we got to adjust the weight accordingly. That's how the system works. That's how the neural network works, right? The basic mathematics behind the back propagation error is basically rooted in calculus. But when we will remain pretty much at a high level in this particular section and focus on what is calculated and how rather than why the calculation takes this particular form, because that will get into algebra and deep level of mathematics and stuff. That's going to take about 100 different lessons. I am assuming you guys are from that background already, so we don't have to touch that area at all. So basically this part, the back propagate error, is broken down into two different sections. One, the transfer derivative, right? And then the two, error back propagation. So that's pretty critical. So transfer derivative is what this particular code calculate the derivative of a neuron output is all about, right? So given an output value from a neuron, we need to calculate its slope, how the calculation happens. Now we are using the sigmoid transfer function, the derivative of which is calculated like, derivative equal to output multiplied by 1.0 minus output. It's as simple as that. That's the formula used for this particular thing. So basically, if you look at this code, the function named transfer underscore derivative, which implements this particular equation. Equation is what? The derivative equal to output multiplied by 1.0 minus output. That's the equation. It's simple, guys, isn't it? Well, yeah, it's pretty simple. So this is how we debug the error when we are back propagating from the output, the final output layer, to the hidden layer and to the input layer, and then correct the weights and send back the data into the neural network. That's how this works. Anyways, so enough said. I'm going to come back to you in the next lesson. We will get into more deeper with forward propagation error. Guys, it's pretty interesting. We are creating artificial neural network which is equivalent to human brains. So, right, it's going to get more interesting. I will see you soon. Goodbye.